So welcome everybody to our innovation showcase. Today's topic is about network reliability. Today's agenda will run for about 55 minutes. We'll be talking about two of our innovation projects, Project Alarm and Project Prefix. There'll be icebreakers and interaction throughout. It might be a bit different from some of the showcases you've been to previously. There'll be opportunities to speak to fellow delegates. Please do feel free to keep your cameras on and ask questions. And about halfway through this session, there'll be a discussion session as well. For those of you who don't know us, we're Western Power Distribution. We're proud to distribute power to 8 million homes and businesses from the tip of Cornwall across West Wales and all the way up to Lincolnshire. And we're now part of National Grid PLC. I'm a member of Western Power's innovation team. We're a team of engineers dedicated to implementing our innovation strategy. We do this by identifying problems, finding solutions and trialing them throughout our projects. One of the reasons we want to do this is we want to aim to be a main contributor to decarbonisation. And reliability, we think, does come under that heading, but reliability is a means in its own, it is an endpoint in its own right as well. We're passionate about using our innovation funding in the best way possible to make sure we create value. We want to do this by working with the best people to achieve excellence together. So the first interactive exercise we're going to do today is just a little Zoom poll. So in a moment, we're going to launch a Zoom poll. It will come up on your screen and you can vote for one of the answers that you think is the response to this question. And the question we'd like you to think about is, actually, we're going to have to let you vote on two items. So it's what two items are the most important to you and your family about how Western Power manages power cuts. So this might be, is it about fast restoration for you? Or do you worry about the vulnerable members in your community? Do you want to see faster response to those? Is it important to you that you're told what has happened? Or is it important to you that you're told about why it has happened? Or being told about when it will be fixed? And within all of that, how important is it to you that there's accuracy of those updates? So I'm just going to launch those polls. So hopefully you can all see that question and that poll on your screen. So please feel free to vote. We've got the votes coming in now. There's still opportunity for those of you who haven't voted yet to vote. Okay, thank you. We'll bring that to a close and share the results with you. So I think fairly overwhelmingly, one of the most important things you've told us today is that it's the fast restoration that matters, followed by being told about when it will be fixed. And the stragglers on this poll, but not insignificant, are accurate updates as to when things will be fixed, followed by attending to vulnerable members of the community and being told about why it's happened. So thanks for participating in that. I'm just going to move on to a second interactive moment. We're going to call this an icebreaker, and it's an estimation game. And the estimation game we'd like you to have a think about is, for WPD's average customer, how long does the average power cut last? You can participate in this by, in the top right hand corner, you can see a QR code. Alternatively, you can go to menti.com. And there's a code on there. And by typing in that code, you'll be able to type your answers onto a screen. So I'm just going to share the response on this so people can type as they go and they can see what's coming back. So we've got 25 minutes, 4 hours, 2 days, 1 hour. So please feel free to put your thoughts in here on this one. 5 minutes, 30 minutes. We'll give you all a few more moments on that. 2 minutes there as well. 1 hour. So the average duration of a power cut across our 7.9 million customers is actually 24 minutes. And I think we've actually got 1 or 2 entries there that are very, very close to that figure. So I hope that was an interesting little exercise just to get you thinking about the scale of the problem that we deal with. Just moving on to our first presentation, well, our next part of the presentation, it is the question of, we do sometimes get asked about why we need to innovate for reliability. I think this question is sort of answered in some of our customers' experience. If you've ever sat on the phones in a customer contact center, you'll get even more insight in this. So, you know, imagine if you're a member of a young family, you got a young baby, if the baby's not happy and if you've got a power cut, that's the last thing you need. It just adds to the stress of your day. Alternatively, you know, if you're an older person, it can be quite a disorientating situation for them if they're trying to work out, is the power cut in their house, is it outside the house? You know, what can we do here to improve their experience of their electricity supply? And also, we're about to go through the transition. There's going to be a greater transition to heating and cooking to be supported by electricity. And transportation is going to become even more supported by electricity. So our opinion is that it's going to become even more important to make sure we've got a reliable electricity supply, because the importance of electricity is only going to increase. So if we're interested in improving our reliability, where is it we want to be? And in Rio ED2, we've already made a commitment to achieve the lowest levels of power cut ever. We also want to improve the experience of our 8,260 worst served customers. But in the even longer term, wouldn't it be great if we can bring all networks up to the same level of service so we don't have to differentiate between worst served customers and our normal customers? We want to make sure we've got resilient networks for electric heating and transport. So how do we get there? Well, the first thing is we think we need to get better at risk identification. And there are going to be 1 or 2 work streams coming up in early 22, where we're going to be reaching out to our supplier base to help us understand what our options are here. And this will be some of our first business innovation projects rather than NIA innovation projects. We also want to be able to enable early interventions. What do we mean by early interventions? It's getting onto power cuts before they happen is where we want to be. And this is where our 2 projects that we're going to talk about today come from, and that's Project Prefix for HV, Project Alarm for LV. We'll talk about our Project Alarm first. So this is automatic location of arc faults through remote monitoring. Why are we doing this project? Well, LV faults are about just beneath half of our CML and CI. We'd like to reduce that. LV power cuts can be quite challenging to locate as well. Whereas our faults on the HV and HV system, it's often quite apparent that they're there. LV faults can be quite tricky because they might blow a fuse. You try and locate the fault and you can't find it, and you put the fuses back in and the circuit's back on. So did you have a fault in the first place? They're very tricky to go after. We also think there's some opportunities coming off our AD2 monitoring strategy, where we're beginning to use LV monitoring devices to increase visibility of the network. It just so happens that those devices can help us detect faults before they happen as well. Project Alarm seeks to demonstrate a technical alternative and lower cost approach to identifying the location of transient LV faults. And it assesses the effectiveness of the associated distance to fault calculation that can be within these devices. On this particular project, we've partnered with Lucy Electric Grid Key, and the project has been running from September 2019 and will be running through to April next year. And it had a budget of 500K. On the right-hand side of this screen is a picture of the device that we've used to start building this capability. It's called a grid key 318 substation monitor. You can actually see on the bottom picture how small they are. They fit within the substation. In this particular case, it's fitted onto the LV feeder pillar door, and you can see the coils coming off the door, going around the cables beneath the fuseways. Very small. Broke our project down into 2 phases. The first phase was really about the hardware. It was about testing the version 1 algorithms and the first trial of the data capture hardware and cards within the grid key. Once we completed phase 1, we took stock of the technology, took some technical learning back and improved the technology to move into phase 2, where we started looking to verify the technology, test the rationale for the trial, and engage with the business as usual field teams to start showing them how this could help and to start getting their feedback about whether they thought it could help. Here, some conversations as we go throughout this project about pecking faults. Some people might call them transient faults, but really physically, what is this? So a pecking fault is where the insulation on a circuit gives way and you get a large spike in current and it comes back down again, but it doesn't manifest into a steady state power system fault big enough to blow fuses. You can observe this through a large spike in current, and that spike in current will change not only its magnitude, but also its characteristics as you progress through the deterioration process. And it also has an impact on the voltage waveform that you can see on the left-hand side. So on the left-hand side, you can see that a bite's been taken out of the voltage wave, but on the right-hand side, you get the large spike in current. And these pecking faults manifest themselves into activity over time. So the more pecking faults, you start getting a bit of an indication about how bad a particular circuit is, and sometimes it might actually blow fuses. So an unhealthy circuit might be pecking away, gradually going towards a permanent failure, whereas some circuits might not have any pecking faults and they're actually quite healthy. And in this particular project, it's been the active sites that have had high levels of pecking faults and fuse operations that have created a lot of the interesting stories. But the rate of pecking and the actual manifestation of what's going on in the mains waveform is deep underneath the hood of this business proposition. To make this actually useful to customers, we need to exploit that information. And to do that, there's a couple of things we need to know. The first set of information is, well, where is the defect? Because if we know where the defect is, we can do something about it. Project Alarm developed a methodology to actually start estimating that. And that was by tracking the location where these pecking faults could be, by building up an insight into how resilient that prediction of where it could be was. And then once you know that, you can overlay it onto a network geographic map to help you start saying, well, where should I start looking for physical manifestations of this defect out in the real world? So during phase 1 of the project, we did have quite a lot of new learning points. And we did detect pecking faults on 25 out of 26 monitors. So that indicates that pecking faults aren't the only indicator of what state a circuit is in. So there are other indicators. We also made improvements on the distance to fault analysis based on field results to allow it to predict the location better. And based on these analysis approaches, we started giving updates to field teams on potential non-fuse operating locations that could potentially be of interest to them to avoid CMLCI. And we started to locate the position of a fuse operation, and actually repaired this particular case based on a predicted distance to fault. We also came up with some learning on the actual physical installation, which was based on the flexi sensors that go around the fuseways. And there's some very good learning points about how you put them around the fuse handles and the sensitivity to temperature. Phase 2 took the refined information, we started verifying it against additional technology just to prove the reliability of the algorithm. We did this by aligning the distance to fault algorithms within the grid key against an additional device, which is called a TDR device, time domain reflectometry. And that was to prove via two methods whether they both aligned. And if they both aligned, then that was a very good sign of the technology that's been developed. We did this and we got some really good results in at least 3 instances. So in Fairfield Crescent, which was up in near Milton Keynes, we found that the defect that had been measured on the distance to fault aligned with the TDR, and this was actually verified to be next to a lamppost that had been in a road traffic collision and had been damaged. We also actually got a much deeper case study on a feeder which fed, we called it the Victoria Road fault. And we've got a sequence over time where we first noticed the defect in November 2020. We got a distance to fault prediction. The distance to fault was in the right ballpark, but it had significant uncertainty, so we weren't really prepared to do anything with it. And in July 21, there was a fuse operation, and we put a smart fuse in as a result of the fact that we knew there was a defect here and we thought it was likely to go again. And the interaction of the distance to fault methodology and the smart fuse meant we could start shrinking the uncertainty margin. And we started getting an idea where the distance to fault was at 91 meters with an uncertainty of 5 meters. That put it outside a particular house. We'll call it house number 46 in this case. On the 31st of August, we had another protection operation, and this time we actually got a physical evidence above ground of where the fault was. And it was located 2 doors down from the prediction we made earlier in July. And I think that gives an insight into the magnitude of the usefulness of this kind of technology. We were able to predict where the fault was to a relatively high level of certainty ahead of a permanent fault. And it's that kind of information that we're interested in ED2. By using this kind of technology in LV fault management, we expect to become more efficient, and we're keen to lead the way in this field. Proposals are under discussion in our policy teams about how we actually extrapolate this into the scale of business as usual operations. And we're looking at investing our own money into how we make this happen. That draws a close to Project Alarm. We'd just like to ask you our next set of feedback questions. And again, this is going to be a Zoom poll. And the question we'd like to ask you is, during a power cut, what 2 items would you and your family be most worried about? So might it be loss of supply to the freezer, loss of supply to your electric vehicle, or if the kettle stopped working? For those of you of teenagers, is there a worry about loss of supply to Wi-Fi? Is it the loss of supply to oven or the hob that worries you, or the loss of heating, or loss of mains to computers and TV? So I'll just launch that poll and we can gather your opinions. Okay, so about half of you have participated so far. So almost there. With the last 25% of you, please feel free to vote. Okay, I'll start bringing this to a close. We have some clear winners. So loss of heating was a source of major concern to you all. The next one behind that was loss of supply to the freezer. Loss of Wi-Fi, loss of mains to computers and TV. Interestingly, loss of supply to the EV, loss of supply to kettle were further down list of questions that you all voted on. So thank you for that. That was all very interesting. Now we're going to move on to one of our newer projects. This is called Project Prefix. Whereas Project Alarm looks at the low voltage system, Project Prefix looks at the HV system. And what I mean by HV is the 11 kV and the 6.6 kV systems. It's the last voltage before the final transformation to the end customer. The HV pre-fault proposition is a bit further behind in development, the LV. And there's some very big differences between the LV and the HV system. Whereas at low voltage, there's traditionally been much less visibility. At high voltage, there's been more visibility, but there's also a much greater penetration of intelligent devices that sample the system at higher frequency. So we would like to start taking advantage of that higher resolution monitoring, not just from pre-fault specific devices, but also to use other devices that are available. This might be protection relays, or it might be fixed harmonic disturbance recorders. There might be other devices that are coming to market as well. We'd like to be able to take advantage of all of these to contribute to our knowledge of HV pre-faults. And that's important because we want to get this at the right price point. If we took a strategy where we were putting one-off special devices dedicated to pre-fault on this pre-fault detection, that increases the cost of the proposition. Whereas if we can take advantage of devices that already fulfill several use cases and add on prefix capability to that, that makes these devices even more attractive to us because we can stack the value from existing equipment. We also want to make sure that these devices can interoperate on the HV pre-fault proposition. We don't really want to be tied into a particular vendor proposition for pre-fault. We would like pre-fault ready devices from different manufacturers helping us. And even if we get the ability to look at the mains waveform and to contribute that information to us, we need to be able to act on it. And that's where automation of the analysis comes in. And automating the analysis such that we can have easily assimilated output to our operational teams so that they know where the risks are and what to do about them. So the way we'd like to do this on Project Prefix is we would like to establish interoperability between different devices, which may be between different relays, harmonic disturbance recorders, or smart fault passage indicators out on the system, and have them all reporting into a common database that WPD look after. And then we could then run analysis on that database and output operational dashboards. This is an NIA project that's been funded to the 1.6 million and 180k of Western Power funding. It's running from October 2021 to February 2023, and it covers 20 primary substation groups, and that's across Coventry and South Devon. And our aims here are to start working towards a scalable HV pre-fault proposition and to develop an approach for interoperability of high resolution monitoring and to trial pre-fault automated dashboards and analysis. And we're pleased to be partnered with Nortec on this project. Our progress to date on this is we've ordered equipment and we're beginning to write user requirements, and we're underway with site selection, and we've already completed that for the primary substations, and we're beginning to plan installation training. We expect to start gathering data from Q1 2022 with platform readiness in Q2 2022. This is quite early on in the Prefix project, and we'll be giving you more updates on our website and on our future showcases as to how we're getting on with this. We'd now like to move on to our discussion session. This is going to last approximately 30 minutes. And the first part of this is we'd like to hold a discussion on your opinion of our work so far and plans for the future, and also to provide an opportunity for you to ask questions on the projects we presented so far. The way you can participate in this discussion is if you want to put your hands up on Zoom, and you can do this by looking for yourself on the participant screen. Click on the ... button, select raise hand, and we'll look out for your raised hand on my display. Alternatively, you can do that in your Zoom mobile app as well. I'm also going to be showing a QR code on the next few slides as we do the final stage of today's presentation. That QR code will take you to our survey, our feedback form on today's presentations as well. We would really like you to give your feedback on the presentation. as it allows us to make these events better. And if you'd like us to follow up with anything particular, please do put your name in there as well with your question, and we can follow up on that. Alternatively, please put any immediate questions that you'd like to ask in the chat function. Just looking through some of these questions already. So pullback. Thanks for your question. What percentage of faults or CML/CI is at LV rather than MV/HV? We can give a fuller answer on this, but broadly, the LV and the HV are similar magnitude, and they constitute most of our risk for CML/CI across the company. EHV faults at 33 and 132 kV are much lower than LV and HV. Richard, you have asked us, can you define the scope of risk identification? Do you aim to quantify probabilities of various types of supply interruptions? Do you use the term risk in the formal sense of probability time consequence? So our thinking here is, firstly, we want to understand the probability of which circuits are going to trip. We want to get a much greater insight into that. And then there is, of course, the consequence. So it's the numbers of customers do come into this, but there's also questions of remoteness of customers as well. So I think we want to look at the risk in the round and to understand what are the most important circuits to look at as a way of getting the process variables CMI and CL down. Tom Storr, you have asked us, are you tracking other data on the state of the network, or does the telemetry only relate to cuts? We do track a lot of data on the network, so telemetry from the alarm project and the Prefix project is a much deeper form of telemetry. Traditionally, we have gathered telemetry on the network which relates to just the RMS level of current and voltage. These two projects will allow us to take that measurement to a much finer level of granularity. Okay, Richard Hanks has asked, are you planning to use any specific data standard to enable the prefix data to be combined, i.e. SIM? So the way Prefix is going to work is that it depends on a network model, and we are looking at several ways to do that at the moment. SIM might be one of those, but we might be using ultimately it all comes down to just to having an impedance topology model within our back-end system. SIM is one of those candidates there. Just carrying on with that, Morris, you have asked, alarm project seems similar to the presence unit you have liaised with Camlin, understand the crossover of the device to the Lucy units. Could you give us more context on your question, please, Morris, if that's possible?
Yeah, so thanks for the presentation, Paul. So it's Presense, which is a device developed by Camlin, which is focusing on the LV monitoring, and they essentially fit in LV boards similar to what the Lucy unit you're developing there is. And what it's essentially doing is looking at developing faults on the network. And I think there's a lot of crossover with obviously within your own project and obviously the device they've developed. I'm just wondering, was there any, I suppose, liaising with Camlin in regards to that? Because I'm assuming you're going through the hardships now of installations of these devices. I don't know if you're doing them in a live manner, and obviously collating data and looking at what value that data is providing to you, but it seems that they've done something a little bit similar, and I'm just wondering, did you have any actual liaising with them to understand if was there any crossover?
No, there hasn't been any liaison with Camlin. Really, what Alarm was just proving to us the viability of the general prefab proposition, and as I mentioned, we're now beginning to come off the back of Alarm and actually look at how we roll this out to business as usual, and the questions there will we'll start looking at what's the wider strategy for rolling this out and who do we need to be engaging with.
Okay.
Martin, you mentioned that you wanted multiple suppliers to provide technology onto the 11 kV network. Does this apply to the data analysis? I think our immediate goal for Prefix is just to show that we can get data from different devices all lining up in a manner that we can use data from different devices. There may be opportunities to start developing different algorithms and to see who's got the best algorithm to do this. But that is a bit further down the road on this as well. So immediately our perspective is just to make sure that we can build a platform so that we don't have vendor tie-in to pre-fault devices. Thank you for your comments there, Steve. It's nice to see you enjoyed it. And if there's anything else you'd like to follow up on, please do. And David, thank you for your project as well. Your quick message on the RESO project. I'll be glad to follow up on that with you as well. So if you could put your contact details in the QR code for the project feedback, and I'll be sure to follow up on you with that one. Are there any more questions that people would like to ask either in the chat or in person? Okay, Sam, thanks for raising your question. What's your question there, please?
Thanks a lot, Paul. Really informative presentations. Just interested, you alluded to there being some temperature dependency around fuse handles in the alarm project. Are you able to expand a little bit on the learning out of that particular part of the project? Thank you.
We might even have Paul Beck on the line, and I wonder if, Paul, you'd like to just give us your first person perspective on this.
Yes, it was a site just north of Milton Keynes where we had the problem, and we couldn't get the sensors around the outgoing ways just because of the construction of the board. It was an open board, so the sensors were put around the fuse handles, and so they were touching the back of the fuse effectively. And what happened was that there was actually a fuse operation, so the fuse got incredibly hot and managed to melt through the outer casing of the sensor, to the point where the inner winding of the sensor actually made contact with one of the stalks. So we managed to get 230 volts into the grid key unit where it's expecting about 25 millivolts. So it didn't do us an awful lot of good, it has to be said. We've come up with an alternative installation process which puts a thermal sleeve effectively just to hold the sensor away from the fuse. We've actually seen it with a couple of other network operators as well, overseas rather than UK. So now we regularly recommend that you use some form of thermal sleeve around the flexi-Rogowskis if you're going to go around either the buzz bars or the stalks or the fuse itself. Hopefully that's answered that.
Thanks a lot, Paul.
Paul, just ask a question. Sorry, it's Morris Lynch here. Sorry for following on, but it's a really good discussion point. Have you thought about using the actual fuse handles with inputs on them? So there's voltage input, there's fuse handles out there with voltage inputs and temperature inputs. I think they're created by Schneider and they do most actual boards. So was there any thought maybe using those actual fuse handles for this project?
You want me to answer that, Paul?
Yes, please do, Paul.
Yeah. That's exactly what we did use. Was the well, both Lucy Electric and Schneider make modified handles. I think there's a couple of other companies that do as well. So basically, it's an adaptation to the fuse handle that does it. You end up with a 4mm banana plug on the buzz bar side of the fuse. And that's what we primarily use. You typically don't use them on open boards, but definitely on a shrouded board you would use that. I've not come across with one with a temperature sensor integral to it. That is something that we've thought about in the past. But yeah, and I believe I'm right in saying, Paul, that this is it's the preferred method of connection for WPD in terms of getting voltage tap.
Right. Thanks for your comments there, Paul.
That's okay.
Just going to move on to another exercise. One of the things I think we enjoy when we've managed to do these events in person is we actually like seeing how different members of the industry are interacting with each other. And we've been trying to come up with a way to foster that kind of cooperation across the industry in these virtual events. We'd like to do an event now, which we're calling 1, 2, 4 all. And this is a way of actually trying to just do a bit of quick brainstorming across all of you. It's called 1, 2, 4 all, because we'd like you all just to stop for 1 minute and to have a think about what is your opinion about what should be our plans for future resilience. And then we're going to start doing a very quick breakout room where you'll be put with a second person for 2 minutes. And we'd like you to discuss again that question, what should our plans for future resilience work include? We're then going to join those 2s into 4s. You've guessed it, you'll have 4 minutes to discuss amongst the 4. So hopefully what you'll see is there's a gradual filtering and refining of opinions. And then at the end of all of this, we'd like a spokesperson from each of the 4 just to recount the distilled output from that process. And we're really interested in listening to that output. It might reveal things to us that we haven't thought of yet. So if there's any questions on that, please do ask them before we proceed. Otherwise, we'd like to put you into those groups. We'll just give 2 moments for people to put their hands up if they'd like to check. And I'm not seeing any hands up. So I'll also put that question in the chat so that you can all see it. But we'll start putting you into the groups. Welcome back, those of you who are back. We'll just let everyone else come back together.
Sorry, I think I hit the leave button a bit too early, probably.
No trouble, no trouble. We'll just let everyone else come back if it's into. Okay, and I think we've got everyone back. I hope you've had a good discussion, everybody. Just before we start getting the feedback from your rooms, please do remember, we would really like to get your feedback on today's event. So you can either use the QR code there or the SurveyMonkey link. It'd be great to have your opinions back on this event. Just whilst you're doing that, if we could just start the next part of our discussion by going through the various rooms. So room 1, which was Alex, Clark and Morris. Did you have any opinions that you'd like to share with us?
Yes, and I was chosen as the spokesperson. So I can only speak about low voltage. High voltage is not my specialty. So I think everybody agrees that what happens between a low voltage distribution box and the end customer is just a big black box. It's unknown. So we believe that having better monitoring and control of a low voltage network, it's one of the things that has to be looked at.
Is there anything, when you say better monitoring control, is there any opinions on what the difference could be? Is there any what might help?
We just added further to that as well, that an LV control room. So at the moment, we all have HV control rooms in our various DNO groups. So LV control is a thing that's going to be coming up and predominantly take focal point going forward. We think the HV is quite vast, but the LV is quadruples that in every sense, doesn't it? So I think LV control in terms of feedback to our customers, identifying faults, and having that own control room entity, I think, will be crucial.
Thank you, Alex and Morris.
Thank you.
Okay, so room 2, which I had as Chris, Richard and Vincenzo.
Yeah. Hi, Paul. Good to see you again. Long time.
Hi, Chris.
So we were talking about, I suppose the network is aging. You're going to be putting additional load through those from EVs, heat pumps, whatnot. So maybe some prioritization or additional focus on aging networks. There was discussions about the increased reliance on electricity, and potentially that might lead to a higher value of lost load and the subsequent impact or increase in CI/CML incentives on that to accommodate that. And then finally, it was really on the increase in data requirements, data flows, and the processes to actually handle that sort of we're at the early stage of that, but that's going to be a mountain of work in the future managing that.
Okay, thank you, Chris. And I think it's the final room, which was David,
yep,
Richard, and Paul.
Yeah, thank you. So I think to summarize our thoughts about future plans, it's about joining up this whole area of work with other areas of work in terms of how can this help them and how can they help this piece of work on resilience. So we came up with multiple examples where these things overlap. For example, in understanding losses and their effect on the lifetime of assets. That they're connected. So we don't want those to be in separate work streams of innovation. We also looked at power quality and also the area of DSO. So both of those might affect the operation of people's appliances in their home. And then you start to blur the boundary with those separate areas of work. So I think the point was made that the areas, feels like the nuclear industry have a very clear definition of resilience, and we need to tighten up what we mean when we say resilience and where it fits into the overall picture. So in short, perhaps a piece of work to position this and make it more joined up with those other initiatives. Help me out, guys, with one or two of the other examples that we mentioned.
You covered it quite well there, David, but I think one of the other suggestions was demand side management, with the objective being to manage balance supply with demand rather than manage congestion in the network.
Thank you. So I mean, there's some really interesting points there. So we've got the LV control room and how that actually fits in with the monitoring strategy we're planning, prioritization of networks and specifically aging ones. The question of what is the right value of lost load for the future, we've taken there as well on the data flows. I found the conversation about what is the definition of resilience. That's a very interesting point. I was just wondering if anyone's got any other opinions on what should be a definition of resilience that we could draw out here at all.
I'd just like to add one more thing, Paul, because David's question got me thinking. So I think a lot of organizations are introducing these zero carbon technologies on the network, voltage optimization or whatnot, because we have to. It's an actual route that we have to go down as obviously network operators. But I suppose the one thing that we fail to forget is that sometimes, and I don't think we fail to forget, but sometimes we may overlook, is that the impact of these systems on the network can obviously cause an impact on our customers, particularly generators and heavily HV consumers. When you're trying to reduce demand on the network or optimize the volts, that can have a negative impact on unhealthy networks that are operating for various reasons, and just does cause a lot of actual issues and concerns. So I think there's a piece of work that'll need to be done on educating not just private network operators, but manufacturers in terms of what technologies we're introducing on the network and how that may impact them as an actual consumer. Because I don't think we've filled that gap as of yet. Particularly, you see a lot of actual, and I'm just using for an example, hospitals and other actual organizations. They use equipment and scanners and voltage control, not voltage, but voltage. Equipment in their actual on their network that operates between 250 260 volts. We all know that that's not actual healthy, but I've seen actual buildings and organizations who obviously import equipment from Spain, Germany and whatnot that don't meet the characteristics of the UK and Ireland market. So I think there's a challenge there, particularly about all this technology we're introducing essentially, and how we educate not just private networks, but obviously manufacturers as well about the equipment they're making and putting into situ, because I don't think any organization has filled that map or actual remit as of yet, I meant to say.
Okay, thank you, Maurice. We're beginning to reach the end of today's session. As I've said already, I really appreciate it if you could give us your feedback on today's event. I'd like to thank you all for your participation. not only with us, but also amongst each other. I think that makes it a more interesting event, is to hear other people's opinions. And if you do have any further follow-up questions, please do put them on the feedback form and we'll make sure that you get a response. So with that, I'd like to thank you all and say we'll see you next time. Thank you for coming.